Okay, so we have a position function here. S of t equals negative 4.9 t squared plus v naught t plus s naught. We're talking about the height of an object in meters, and we're talking t for seconds. It's thrown upwards with an initial velocity of 9.8 meters. That's a typo. That should say meters per second, not meters per second squared. So let's go ahead and cross that off. That should not be there. An upwards initial velocity of 9.8 meters per second and a height of 14.7 meters. And we want to know A, what time does the object hit the ground? So first off, we need to write our equation. So S of t, the height of the object with respect to time, equals negative 4.9 t squared plus the initial velocity, which is 9.8 t, plus the initial height, which is 14.7. And now I want to know at what time the object hits the ground, aka if you can picture this situation, I want to know, boom, what this x-intercept right here is. So I need to factor this equation. So I'm going to rewrite S of t in factored form. So I'm going to factor out that negative 4.9. So I'm going to pull that out front. And what am I left with? Well, I'm left with t squared. 9.8 divided by 4.9 is going to be plus, I'm sorry, not plus, because recognize the 9.8 is positive, but the 4.9 is negative. I'm pulling out the negative, so that's going to become minus. 9.8 divided by 4.9 is 2t. And then again minus, because 14.7 is positive, so minus 14.7 divided by 4.9, which is indeed 3. And now I can factor this, negative 4.9 times t squared minus 2t minus 3. So what two numbers multiply to give me negative 3 and add to give me negative 2? And I am going to get x minus 3 and x plus 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So that's how it factors. The only x-intercept that makes sense is the positive one, and that's coming from that factor right there. So x equals 3 is my answer to A. So I'll say t equals 3 for A right there. Now find the velocity at the time of impact. Well, the time of impact is 3 seconds. It's when it hits the ground. And so we need to take the derivative of this function. So I'm going to take the derivative of the original function we wrote in standard form, because then I can just use the power rule. And so I'm going to get s prime of t, which is v of t, is going to equal 2 times negative 4.9, which is negative 9.8 t, plus 9.8 from that 9.8 t there. And then the derivative of 14.7 is 0, so that goes away. And now I want to know the velocity at the time of impact. The time of impact was 3 seconds, so v of 3 equals negative 9.8 t plus 9.8, which I'm first going to simplify to, sorry, I meant to not write t, but I meant to substitute in that value. I erased 9.8. I meant to substitute in that value of 3 for t. But notice I have 3 negative 9.8s and 1 positive 9.8. So that's going to simplify to negative 9.8 times 2. Took away one of those negative 9.8s. And that is going to be negative 19.6. And we're talking about velocity, so our units are meters per second. So there's my second answer. My first answer was t equals 3. Second answer, so part B here, is the velocity at the time of impact is negative 19.6 meters per second. And then C, find the time when the velocity is 0. Well, we have two different ways we could do that. We could complete the square, or we could use our derivative function. and set it equal to 0. I'm going to go that route. So I'm going to say that 0 equals negative 9.8 t plus 9.8. And so we're going to solve for t. So we need to subtract 9.8 from both sides. So minus 9.8 equals negative 9.8t. So divide by negative 9.8t to get t equals 1. So the object has a velocity of 0 when t equals 1. And think about what that means. That is talking about the maximum value of this function. So this graph is like totally inaccurate. It should be more like something looking like this. We know the x-intercept is at 3. Should look something like that. Where that's 1, 2, 3. And, okay, finally, part D, find the maximum height the object reaches. Well, the maximum height is going to be that maximum value, which corresponds to the derivative of 0, which happens at a time of 1. So I can just plug into my changing colors pens and I distracted myself. I'm going to plug into my original function because I know the time where I'm at my maximum height, 1 second, when I'm at that maximum value when the velocity is 0. And now I need to find the height. So I'm going to plug in, find s of 1, which is going to be negative 4.9. 1 squared is 1, plus 9.8 times 1 is 1, plus, there's my 8, plus 14.7. So add it all together. I'm going to do this. I know that this negative 4.9 is going to bring that 14.7 down to 9.8. So now I have 9.8 plus 9.8, which I know is 19.6. So the maximum height the object reaches is 19.6 meters.